Hello my dear students. Today we are going to continue chapter 5. We are going to continue the discussion of hydrocarbons. We are going to discuss the unsaturated hydrocarbons, which is aromatic compounds. We are going to discuss the benzene and the nomenclature of aromatic hydrocarbons, and we are going to discuss the preparation and the reactions of benzene. So let us start. Benzene that has molecular formula C6H6. The structure formula of benzene. In 1931, the German scientist Keckel discovered its hexagonal cyclic shape, which contain alternating single and double bond, as shown on the screen. Here the two structures of the alternating single and double bond, and the ring here between the two positions, indicating that the 6 electrons of pi bonds are delocalized at certain carbon atoms. Now we are going to discuss the preparation of benzene in industry. From coal tar. During destructive distillation of coal, it means heating in the absence of air, it decomposes into gases and liquids. And the most important of these liquids is heavy black substance is known as coal tar. And by fractional distillation of coal tar, we obtain benzene at temperature 80 till 82 degrees Celsius. The second way for preparation from aliphatic petroleum derivatives. From normal hexane. Normal hexane is passed at high temperature on surface of platinum as catalyst. This method is called catalytic reforming method. As the equation proceeds on the screen, the normal hexane, by the presence of platinum and heating, here it gives benzene and 4H2 is produced. My dear student, notice that when normal heptane is passed at high temperature on surface of platinum as catalyst, methyl benzene, which is called toluene, is formed. As shown on the screen, normal heptane in the presence of platinum and heat, it gives toluene or methyl benzene and releases 4H2. Now, from polymerization of acetylene or trimerization of ethine. By passing acetylene vapor or ethine vapor in red hot nickel tube, it gives benzene as shown on the screen, which is called cyclic polymerization or trimerization. Third way for preparation from phenol. By passing phenol vapor on surface of hot zinc powder, which reduces phenol to benzene. As shown on the screen, phenol plus zinc here and heating, it gives benzene and zinc oxide is produced. The preparation in lab. From dry distillation of sodium benzoate with soda lime. As shown on the screen, sodium benzoate plus sodium hydroxide in the presence of calcium oxide, and my dear student, you remember that sodium hydroxide is caustic soda, calcium oxide is quicklime, and the mixture of sodium hydroxide and calcium oxide is called soda lime. This dry distillation produces benzene and releases sodium carbonate. Now we are going to discuss the nomenclature of benzene derivatives. The name of monosubstituted benzene is derived from the name of the atom or the group which is attached to the benzene ring followed by the word benzene. As shown on the screen, nitro group is attached to benzene ring, so its name is nitrobenzene. Chlorine atom attached to benzene ring called chlorobenzene. Hydroxyl group attached to benzene ring is called hydroxybenzene or phenol. Methyl group attached to benzene ring is called methylbenzene or toluene. So we have give reason in this point. When a group is introduced into benzene ring, only one compound is formed. Because the 6 carbon atoms are similar, so the entering atom or the group attacks any carbon atom of benzene ring. So exercise for it, nomenclature of some aromatic compounds. As shown on the screen here, my dear student, we have longest continuous chain contains 3 carbon atoms. So its name it will be propane, as all the bond between the carbon atom is single bond. Here we have branch has phenyl radical C6H5, so its name it will be 2-phenyl propane. And another example here, 2 benzene ring attached by single bond is called diphenyl. The name of di-substituted benzene. So we are going to talk about directing groups. When a second group is introduced in the benzene ring, there are 3 probabilities for replacing hydrogen atom called ortho, meta, and para. As shown on the screen, the substituted group A at carbon number 1, and we have numbering 2, 3, 4, 5, 6 for other carbon atoms. The position number 2 and 6 called ortho, 3 and 5 called meta, 4 called para. And the reaction depends on the attached group A. So we have ortho and para directing groups. As shown on the screen, if the benzene has group A and another group B is introduced, so we have here 2 products, main products are produced, 2 main products, ortho position and para position, as shown on the screen. This group A, that ortho para directing group, alkyl radical as CH3, hydroxyl group OH group, halogen atom fluorine, chlorine, bromine, iodine, amino group NH2 group. For example, halogenation of toluene. Here toluene, which is methylbenzene, on adding chlorine in the presence of iron, it gives 2 main products, orthochlorotoluene and parachlorotoluene, and 2 HCl byproducts are produced. My dear students, the IUPAC name for these 2 main products, orthochlorotoluene, it will be 2-chlorotoluene, and parachlorotoluene will be 4-chlorotoluene. The meta-directing groups. Here, my dear student, I'm introducing group B in the compound that contain group A, that meta-directing, it gives the meta compound, and here the groups A may be aldehydic or formyl group CHO, and the group may be carbonyl group or ketonic group CO, and carboxylic group COOH, or nitro group NO2. For example, the halogenation of nitrobenzene. Here the chlorine is added to nitrobenzene and the nitro group is meta-directing group, so forming meta-chloro-nitrobenzene, and its IUPAC name, which is numbering only, so it will be 3-chloro-nitrobenzene. The name of tri-substituted benzene. The carbon atoms in the benzene ring which attach to the substituted groups or atom takes numbers, then the nomenclature is arranged according to alphabetic order for the lowest sum of the position of substituted groups or atoms. For example, here the chlorine number 1, nitro at number 2, bromine at number 4, and alphabetic order it will be 4 bromo, 1 chloro, 2 nitrobenzene. Remember, my dear student, the numbering of the branches must be get the lowest sum possible numbers for the branches. So, my dear student, notice that nomenclature by the IUPAC name consider only the numbering of the benzene ring. Now we are going to discuss the physical properties of benzene. It is transparent liquid immiscible with water. It has pleasant smell. Its boiling point is 80 degrees Celsius. It burns in air with a black smoky flame as its molecule contains large number of carbon atoms. The chemical properties of benzene. The benzene reacts by two kinds of chemical reactions: addition and substitution reaction. The addition reactions, hydrogenation reaction. Here benzene reacts with hydrogen under the pressure and temperature in the presence of catalyst to give cyclohexene. As the equation proceeds on the screen, benzene plus 3H2 in the presence of heat, pressure and catalyst, it gives C6H12, which is cyclohexane. Halogenation reaction. Benzene reacts with chlorine or bromine in sunlight ultraviolet, forming hexahalocyclohexane. So benzene reacts with chlorine in sunlight ultraviolet to form insecticide hexachlorocyclohexane, which is called gamexane. As the equation proceeds on the screen, C6H6 plus 3Cl2 in the presence of ultraviolet gives C6H6Cl6, which is gamexane. The substitution reactions. Halogenation reaction. Here benzene reacts with chlorine in sunlight in the presence of ultraviolet light in the presence of iron 3 chloride as catalyst to form chlorobenzene. As the equation proceeds on the screen, C6H6 plus Cl2 in the presence of iron 3 chloride as catalyst, it gives C6H5Cl plus HCl, and here chlorobenzene is formed. Now we are going to discuss the halogen derivatives of aromatic compounds. Aryl halides are used as insecticides. DDT or dichloro diphenyl trichloroethane. and we have give reason in this point. The DDT has poisonous effect due to the presence of the group CHCl3, which dissolves in fatty tissues of the insects and kill it. Another give reason in this point. DDT was called ugliest compound because of its environmental problems which have appeared during its usage. Now, second type of substitution, which is alkylation reaction, which is called Friedel-Crafts reaction. Benzene react with alkyl halides where the hydrogen atom of benzene ring is replaced by an alkyl group, forming alkyl benzene. This reaction usually takes place in the presence of anhydrous aluminum chloride AlCl3 as catalyst. As the equation proceeds on the screen, C6H6 plus CH3Cl anhydrous aluminum chloride gives C6H5CH3 plus HCl, which is toluene or methyl benzene. Nitration reaction. The benzene C6H6 reacts with nitric acid in the presence of concentrated sulfuric acid, where the hydrogen atom of benzene ring is replaced by nitro group NO2 group as the following animation show. Here, my dear student, we make the reaction of benzene with reacting with concentrated nitric acid in the presence of sulfuric acid as catalyst. Here, the substitution reaction takes place and one hydrogen atom of the benzene is replaced by the nitro group, forming nitrobenzene, and this takes place at 50 degrees Celsius. As shown on the screen, the reaction occurs giving nitrobenzene. Here, the reaction proceeds giving nitrobenzene. As shown on the screen. Here is the equation of the reaction. C6HNO3 concentrated in the presence of concentrated sulfuric acid at 50 degrees Celsius, giving C6H5NO2 nitrobenzene, and water is produced. We have give reason in this point. The polynitro-organic compounds are very explosive because their molecules contain their own fuel, which is carbon besides oxygen, which is oxidizing agent. So burn rapidly, and also due to the weakness of the bond between N and O, NO bond, to form two strong bonds between C and O, CO bond in CO2, and the bond between NN and NO2 molecules, so a great amount of heat and gases are produced accompanied by explosion. Here, my dear student, TNT is 2,4,6-trinitrotoluene, is one of the explosive nitroorganic compound which was produced by millions of tons through the Second World War and is still produced until now. This compound prepared by the reaction between toluene and a mixture of concentrated nitric and sulfuric acid by ratio 1:1. As the equation proceeds on the screen, toluene plus nitric acid in the presence of concentrated sulfuric acid at 50 degrees Celsius, it gives 2,4,6-trinitrotoluene or TNT plus 3 molecules of water. Now, the sulfonation reaction. In this reaction, hydrogen atom of benzene ring is replaced by sulfonic group SO3H group. As shown on the screen, C6H6 plus H2SO4 concentrated gives C6H5SO3H benzene sulfonic acid, and water is produced. The detergent industries. It depends on the aromatic sulfonic acid compounds after treatment with caustic soda to obtain the water-soluble sodium salt. As shown on the screen, the alkyl benzene sulfonic acid on treatment with sodium hydroxide caustic soda, it gives sodium salt of alkyl benzene sulfonic acid R benzene ring and SO3 on A plus water is produced. Here, my dear student, the molecule of detergent is composed of two parts, head and tail. The head is the ionic group sodium salt of sulfonic acid group, which is hydrophilic, and tail, which is long chain alkyl benzene radical, which is hydrophobic. How can we remove the spot and dirts? Adding detergent to water decreases the surface tension of water, which increases the ability of water to wet textile. When the detergent is dissolved in water, their molecules arrange themselves. So the hydrophobic tail of each molecule is directed toward dirt and textile and adhere with them, while the hydrophilic head is directed towards the water, so detergent surround dirt completely. And the friction produced from mechanical rubbing causes separation of the dirts and break them to small balls, as the following animation show. Dear student, we show the detergent structure, head and tail. The ionic head and the tail will be directed in the water such that the tail is directed toward the dirt and textile, while the head directed toward the water, and any mechanical rubbing, the positive heads will be repelled with each other and as small poles, and so the dirts can be removed from the textile as shown on the screen. So the result of the repulsion force between heads of molecules similar charges leads to remove the dirts by rinsing process. So my dear students, we are going to discuss some questions. Choose the correct answer. Phenol is reduced by zinc and produces what? Normal hexane, cyclohexane, zinc phenate, benzene. If you think about it, yes, it will be benzene. The product of halogenation of nitrobenzene is what? Orthochloronitrobenzene, parachloronitrobenzene, orthonitrochlorobenzene, metachloronitrobenzene. If you think about it, yes, it will be metachloronitrobenzene. Next point. Catalytic reforming method of normal hexane produces what? Normal hexane, cyclohexane, zinc phenate, benzene. If you think about it, yes, it will be benzene. Next point. Catalytic reforming method for normal heptane produces what? Benzene, cyclohexane, zinc phenate, toluene. If you think about it, yes, it will be toluene. Benzene may react by what? Substitution only, addition only, elimination only, or addition and substitution. If you think about it, yes, it will be addition and substitution. Dry distillation of sodium benzoate with soda lime produces what? Normal hexane, cyclohexane, zinc phenate, Benzene, if you think about it, yes, it will be benzene. My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed today. So, till we meet again, my best wishes for you.